Right, wanted to redo the quizzes today. So this is number 1, and this is number 2. And I want to write the empirical formula and the molecular formula for each of these. Okay, let's do this one first. Now, again, through the magic of whiteboard technology, I'm looking for an eraser. Let's change this to grams, okay? We're working on 100 grams, okay? Now, I'm going to divide this by 14. I'm going to divide that by 16. 14 because it's nitrogen, and 16 because it's oxygen. So, 36.84 divided by 14 equals 2.631 moles. Okay? And that's of nitrogen. We'll make that another color. We'll do that in a second. And then 63.16 grams divided by 16 is 3.948. 3.948 moles. Clear? Okay, so let's erase some things here to give us some room. Okay, we'll leave that and we'll get rid of this. This is nitrogen and oxygen. Okay? All right, now. So this is nitrogen up top and oxygen below. Nitrogen here. This is nitrogen and this is oxygen. Okay, now, so you would say large over small would be 3.948 moles divided by 2.631 moles, right? And that's going to equal 1.5 to 1. 1.5 to 1. Now, I can get rid of this now. Let me clip this, and I can get rid of this, and I can say that this is oxygen up top, okay? Got to keep your wits about you. This is oxygen up here. Let's make that blue, okay? Make that blue oxygen, and that is nitrogen, okay? Now, 1.5 to 1, you can't round that to 2. You got the nearest whole number ratio. So 1.5 to 1 would be 3 to 2. That would be 3 to 2. Okay? Or if you wanted to look at it in terms of a larger number, it would be 15 over 10. 15 tenths would be 3 over 2. Remember, it's the lowest ratio. Okay, therefore it's going to be N2O3. Now, some of you were a little bit confused. Lowest ratio. Empirical formula is the lowest ratio that two atoms will combine in a chemical formula. It's called the empirical formula. NaCl, 1 to 1. That's an empirical formula. It's the lowest ratio. Okay? The lowest ratio. Let me get rid of this. Okay? Now, I know that this is 14 times 2 is 28 times 48, which would be 28 and 48, which would be 76 AMUs, right? Okay, so that is going to be the formula weight. That's going to be 76 AMUs, okay? Right, now, when you write an empirical formula, technically it looks like this. You write the formula, let's say it's N2O3, and N would be a multiple of these subscripts. Well, n would be a whole number, a multiple. So you'd say molecular weight divided by empirical weight, which would equal 304 divided by 76 equals 304 divided by 76 equals 4. Correct? So that's going to be 4. Therefore, this is the empirical formula. The molecular formula would be N8O12. That's the molecular formula. Empirical formula, lowest ratio. Molecular formula, not the lowest ratio. It's a multiple of the empirical formula. Clear? Okay, so let's just do the rest of it very quickly. Okay, let's do the other one very quickly. Easy? N8O12. Okay, let's do the next one. I'm just going to do it very quickly. See if you can follow. Press pause. So this will be grams and grams divided by 16 divided by 14. All right? 30, that would be 2.174. 2.174 moles, and this would be 4.348 moles. Okay? So then it's going to be oxygen over nitrogen. You'll have 4.348 moles over 2.174 moles, and that's going to be this divided by that. 17 times 2 is 34. You can see that it's easily going to be 2 over 1. Clear? So it's NO2, which has that's the empirical formula. It has a empirical weight of 14 plus 32. 14 plus 32 would be 46. 14 plus 32 would be 46 AMUs, and that's the empirical weight. Okay, good. The molecular weight is 230. 230. So it'd be 230 divided by 46, and that's going to equal 230 would be 5. 5. So that will be, this is the lowest ratio, then you would say a factor of 5, multiple, so it'd be N5010. Empirical formula, molecular formula. Lowest ratio, multiple of the empirical formula. Enjoy your holiday.